Okay, for this week's lab, we're going to be looking at the enzyme catalase. This is an enzyme that is found naturally within animals. And what you need to know is a little bit about enzymes in general. So we're going to go a little bit over what an enzyme is, why they're important, and then the importance of catalase, product, substrate, and your enzyme. All right, so what is catalase? Catalase, like I said before, is an enzyme. This is going to prevent the accumulation of H2O2 or hydrogen peroxide that builds up in a cell, and that usually builds up due to cellular respiration. So if we were to take a look here, our enzyme, and let's pretend this is our enzyme, and our substrate, this is going to be our substrate. And normally you would think of an enzyme working in a lock and key fashion, where you'd have your substrate come in, locks onto your enzyme, breaks the bonds, and then you are left with two products. In this instance, water and oxygen. We now know that it's not so much a lock and key, but more of an induced fit. And what this means is that as the enzyme and the substrate come together, their interaction creates this shift in the enzyme structure that conforms to the actual substrate and makes this ideal arrangement between the two, this ideal binding. And this maximizes the enzyme's ability to catalyze a reaction. And again, the purpose of this is to lower the activation energy for the reaction to occur. The reaction would normally occur anyway, but the enzyme is going to allow it to occur with less energy. We're also going to be using sodium alginate. So the yeast that we're going to be using today will be mixed with sodium alginate. Now this is just a polysaccharide that is naturally extracted from brown seaweed, which is a type of protist, type of animal. And it's normally found in cold water regions. Most people would use sodium alginate in cooking. And so when they are making fake caviar, modern cuisines. You can also use it to thicken pies, mayonnaise, salad dressings. So it's a common ingredient. And what it does is that it actually reacts with calcium chloride. So if you take a look here, we have our sodium alginate. And this normally is long negatively charged, where your calcium contains two positive charges. And so when they come together, they actually produce these linkages due to the charge. And that's what enables you to create these yeast balls, or yeast spheres. So as you know, the enzymes normally have their own optimal conditions based on the particular enzyme. And this is a specific temperature, a specific pH. And what we're going to investigate is how the reaction will change when you change these optimal conditions. So what we're going to be looking at is either temperature, and that's the temperature of catalase, which again is found inside of the yeast. So once you make the yeast spheres, you would then sit them in low temperature for 5 to 10 minutes. And then you would run your experiment as normal. You could also increase or decrease the substrate concentration. And if you did that, you are actually supplying more substrate available to the enzyme. So again, here is your enzyme. And let's say you've got your substrate. Now, if you have more substrate available for the enzyme, you're then going to get an increase in product. So the first thing that we need to do is to make our yeast spheres. And in order to do that, you need to take your yeast and you're going to mix it with your sodium alginate. And then you're going to wait. And then that is going to be dropped so this mixture is then going to be dropped into a beaker of calcium chloride, ice cold, and it's going to form these spheres. And this will be sitting on a clamp, just like this. Okay? Once you've made your yeast spheres and you've rinsed them out, and we've waited, so you normally would wait about 10 minutes for them to sit in the calcium chloride. You rinse them out, and then you're going to take your Erlenmeyer flask, or no, your graduated cylinder, put your hydrogen peroxide into your graduated cylinder. You're going to drop your yeast sphere into the graduated cylinder, and then you're going to time. So record the time that it takes for it to either go down and then back up, or once it hits the bottom to go back up. It's completely up to you, but however you want to time it, it has to be consistent throughout all of your runs. You're going to do this 5 times and then find the average. Once you have done that, we are then going to change a variable. You can either do different temperatures, you can either change the substrate. Whatever you decide to do, either you've increased the temperature, you've decreased the temperature, you've increased the concentration of substrate, or you decreased the concentration of substrate. You're then going to do this 5 times and take a look at the average. Top, and that would be your relative rate. You also want to calculate the relative rate. So you're going to divide the distance the spheres rose by the time it took them to rise. And so if you have your graduated cylinder, make sure that you have measured out with a ruler the distance that 50 milliliters is. And then you are going to record the time, have somebody record the time from the bottom, and that would be your rate. Sources of error. If your spheres are different sizes, maybe some have tails, some are much, much bigger. If there are different sizes, you're going to get different times, because this will definitely contain more catalase than something like this. So when you pick your spheres, make sure they're all about the same size. Also, when you make up your concentration of hydrogen peroxide, which you should do each time that you change your variable, you want to make sure that you make up that concentration the exact same way. Time can also be a source of error if you're not timing it the exact same way each time. So make sure that you can write down the different sources of error. And that is it. That is the lab for this week. So make sure that you have read over the section on enzymes, that you've gone over how temperature and concentration can affect an enzyme. You need to know what an enzyme is, what the substrate is, and what a product is. Also make sure that you understand what catalase is and how that plays into your yeast spheres. All right, I will see you guys next week.